eDNA is a tool that we can easily deploy at scale that sort of makes monitoring more affordable and potentially more impactful.
eDNA is environmental DNA, and all the animals living in the river and on the banks of the river to an extent will shed their DNA, and that DNA will enter the river.
By just filtering the water in an aquatic system, we can collect all of the DNA and the cells that have been deposited in that river, and then we can use that DNA to look at the collection of species that are sort of using that river as their habitat.
Through water filter sampling, we'll be able to detect those organisms and get a profile of biodiversity.
It's a really powerful tool for monitoring ecosystem health because it allows us to understand the biodiversity at a given location without needing to directly interact with the animals, so we don't need to catch them or to visually see them to know that they're there, which means it's a really powerful tool for detecting rare and elusive and cryptic species. In order to effectively protect rivers, we need to at first get an accurate understanding of what is there to be protected in the first place. So by using eDNA, we can quickly and easily get a snapshot of the entire sort of community of organisms that are existing in that environment and understand what the biodiversity baseline is, and then from there we can understand what we need to do to protect that in the future.
The eDNA monitoring we're doing with trace biomonitoring is a method that allows us to capture data from a wide range of taxonomic groups. So whereas traditionally you might have just focused on fish, in this project we're looking at 33 different taxonomic groups, from bacteria all the way up to mammals, and it's just an incredible way of looking at kind of big picture biodiversity rather than individual narrow views of certain groups. Here, the Atlantic salmon in this project will be able to hopefully identify important areas of spawning ground for that species, so we might be able to advise on mitigation work or habitat improvement at times when regulators are struggling to be able to monitor to the level they should be. Methods like environmental DNA are easy ways of us collecting a lot of data on a lot of biodiversity on species we wouldn't necessarily detect through traditional methods.